Warning, the video you are about to see is highly educational. Please note that this may help you on your next biology test. So take out your notebooks and take out your pens. We got the greatest rap video that's ever been. Today's lesson, cellular respiration, the latest energy generating sensation. We've broken it down into 3 stages. It's been going and going since the Middle Ages. The cytosol is where we begin all this, so sit back and let me explain glycolysis. Glucose is a carbohydrate that takes a new state as 2 smaller molecules called pyruvate. The energy this creates is in the form of 4-adenosine triphosphate. When releasing energy, tri turns to di. ATP is to cells, the spinach is to Popeye. These ATP don't come from your imagination, they come from substrate level phosphorylation. A molecule with a phosphate on the side gets that phosphate taken, it goes for a ride. With an enzyme designed to blow your mind when that phosphate and ADP get combined. We have one more acronym to memorize. It's NAD+, but don't get surprised when people say NADH, you'll soon see it carries electrons for the ETC. In conclusion, glycolysis generates 2 ATP, NADH, and pyruvates. We'll follow the pyruvates through the Krebs cycle. There's a tricycle. We're breaking down sugar like the Kool-Aid man. Rapping so well you think I'm in a band. Crushing glucose into ATP. Can't beat that aerobic efficiency. Using monosaccharides for energy production to power each cell's metabolic function. Respiration what keeps you alive, keeping you going so that you can thrive. Pyruvate enters the mitochondria, and as soon as it does, it turns into acetyl-CoA and 1 carbon dioxide. NADH and 3 ATP are forming a side. This is the prep step for the cycle we know. Now it's off to the mitochondrial matrix we go. Acetyl-CoA and oxaloacetic acid combine as citric acid, this 6 carbon masses, reverted through a series of oxidation reactions, back to OAA after energy extraction. Including the prep step, Krebs cycle generates a NADH and 2 ATP for pyruvate. The carbons from glucose can be traced to 6 carbon dioxide released as waste. The cycle also yields FADH2, a molecule that carries electrons too. Like NADH, but not as efficient. But with carrying electrons, it's sufficient. Now all electron carriers are set. Send for the ETC, the best cycle yet! We're breaking down sugar like the Kool-Aid man. Rapping so well you think I'm in a band. Crushing glucose into ATP. Can't beat that aerobic efficiency. Using monosaccharides for energy production to power each cell's metabolic function. Respiration what keeps you alive, keeping you going so that you can thrive. ETC needs little explanation. Hydrogen ions pump to a higher concentration. The movement of ions is chemiosmosis. And respiration WAP will effertosis. Protons diffuse like they're in a race from the matrix to the intermembrane space. Electron carriers undergo oxidation, all in the name of ATP creation. Proton pumps perform active transport all day, causing a concentration gradient to form from the fray. Protons want to travel from high to low, so through ATP synthase they will go. The flow of protons does not go unseen. It causes it to spin like a washing machine. These revolutions generate chemical energy that the cells allocate to power activity. We're breaking down sugar like the Kool-Aid man. Rapping so well you think I'm in a band. Crushing glucose into ATP. Can't beat that aerobic efficiency. Using monosaccharides for energy production to power each cell's metabolic function. Respiration what keeps you alive, keeping you going so that you can thrive. The hydrogen ion is now in the matrix again. React with the final acceptor, oxygen. Oxygen and hydrogen combine on a burst to make water so you can quench that thirst. Respiration will keep going all the time. If it wasn't for a special allosteric enzyme, phosphofructokinase is there to save the day, but all his friends just call him PFK. PFK is there to phosphorylate fructose. He's an important enzyme, but he doesn't like to boast. Let's say you've been respirating all day long, and you've made a million ATP by this point in the song. ATP will fit in PFK's allosteric site, inhibiting PFK by making its shape not right. As ATP is used, PFK is free to continue glycolysis and make ATP. This is a negative feedback loop. Now you can teach us to your study group. That's all I have for this unit, but when we do photosynthesis, you're all gonna lose it. We're breaking down sugar like the Kool-Aid man. Rapping so well you think I'm in a band. Crushing glucose into ATP. Can't beat that aerobic efficiency. Using monosaccharides for energy production to power each cell's metabolic function. Respiration what keeps you alive, keeping you going so that you can thrive. Ha ha ha. This has been a little Benzyme production. Get it? Benzyme? Okay. You've never seen Bill Nye drop a sick beat like this. Or maybe you have. I don't know. Special thanks to Mrs. Przworski for being the best biology teacher. Alright, signing off, Little Benzyme. Wow, I really need to get a better name.